Hi guys, today I would like to discuss about cells and batteries. So we know about more about batteries. So these are the different types of batteries. So let me discuss about batteries first. So battery is a collection of one or more cells, and in the battery certain kind of chemical reactions takes place. So that chemical reaction is cause for the flow of charge. So this is one of the electrical energy source. Nowadays its capacity has increased such a way. So the electric cars, EVs, they are started to run with the help of these batteries. Such new combinations of the chemical compositions are come up, and they are capable of storage electric energy. You will wonder that with a single charge, with one time charge, this Tesla model is capable to go around 440 kilometers. So that is its capacity. Now you can understand what is the capacity of the energy sources. So let us discuss more about these batteries. So these batteries are two types. One is primary, second one is secondary. So primary batteries. So primary batteries we are using. So these are single usable, means one time. They cannot be recharged. So they cannot be recharged. And these are made up of certain electrochemical cells, and in those chemicals the reactions cannot be reversed. So that's the reason they are not reusable, and they will come up with a different varieties, small to bigger. So you can use the cell batteries, coin batteries, in the watches or any electrical equipments, and in the big size up to AA and AAA size. So they are the single use batteries. But when it comes to secondary batteries, in these batteries the electrochemical cells and whose chemical reactions are reversible. So that's the reason when we can use, we are capable of recharging our mobile phones, because our mobile phone contains secondary batteries. So these comes in the four varieties: nickel cadmium and lithium ion, and third one is nickel metal hybrid, and fourth one is very important, lead acid. So I think we know about lithium ions. So that lithium ion is the main content in the mobile phone batteries. And we know about the lead acid batteries. So the lead acid battery is any acid, the one which we can use in the car vehicles. So that is the lead acid batteries. And nickel cadmium, just like cells, nickel cadmium. So these are the reusable. So these comes in the four categories: nickel cadmium and lithium ion and nickel metal hybrid and lead acid. Nowadays this lithium ion are become more famous, and they are the capable of increasing storage, more energy sources. And any battery cells, it contains three main parts. One is anode, which is negative electrode. Another one is cathode, which is positive electrode. The third one is very important, electrolyte. So these are the chemistry terms. I hope you know that. So this is one of the internal structure of a battery. which contains anode, which is the negative electrode, and the cathode, which is positive electrode, and very most needed thing is that electrolyte. Now, any battery is the combination of cell. So to understand much about batteries, we need to understand primarily about cell. Cell is made up of a chemical composition. So we are having primary cells. Under the primary cells, those are called as voltaic cells. So I would like to discuss very first, which is the name of Daniell cell. So Daniell cell is a primary cell, is a primary voltaic cell. So to make a Daniell cell, what are the requires? It needs a copper anode. As per I said, a cell needs or cell or battery needs three main things. One is anode, and second one is cathode, and third one is electrolyte. So here copper anode, here you can see this copper vessel. The copper vessel itself is the copper anode, and cathode, so we can use a zinc rod as a cathode, and here main the component electrolyte. The electrolyte here we are using as a copper sulfate in the liquid form, in the solution form, or in the form of a paste. So to construct a Daniell cell, to form a Daniell cell, we need these things. So the left side what we are seeing is that is the setup of Daniell cell. So let us construct Daniell cell. So here I am going to construct, I am going to show the virtual demonstration for the Daniell cell. So this is a copper vessel, and this is a ceramic plate, and this is my zinc rod, and this is the electrolyte, and this one is one acid, dilute acid. So I think it's better to take, yeah. So the things which is at here to construct a Daniell cell, the first thing here we need is that cathode, so this copper vessel, and the anode is the zinc rod, and here this is the my electrolyte, copper sulfate. Now let's watch the construction carefully. Now we will place copper sulfate in the copper vessel. So the concentration of the copper sulfate here, it is 1 mole. So we can prepare copper sulfate solution 1 mole, and we pour the copper sulfate in the copper vessel. Now here we kept this ceramic vessel. So this is ceramic vessel which is already dipped in the copper sulfate. Now in the ceramic vessel we are pouring diluted acid. You can take diluted any acid, diluted HCl or the diluted H2SO4. So that is the diluted acid. Now we will place a zinc rod in the acid. Now the zinc rod will be served as anode, and the copper vessel itself will be served as cathode. Now it's all over. Now this is known as Daniell cell. How simple construction cell it is. Suppose if I connected this cell to a voltmeter, to know the how much potential difference I am getting. I should say it's exactly the EMF. So we are connecting one connecting wire to zinc rod and another connecting wire to copper vessel. So copper will be acts as cathode and zinc will be acts as anode. And to see the what is the potential difference we can get, we can connect copper to positive since it's cathode. We connect to that positive terminal of the voltmeter, and we can connect that negative terminal zinc rod to anode. So here we can able to see the potential difference. Barely you can notice that. So the potential difference roughly it is showing that 0.75 volt. So this Daniell cell, gives us the potential difference of 0.75 volt is the potential difference we can get if you use this one. 0.75 volt. So that is the potential difference, or we're supposed to say that as EMF. I can talk about that EMF later. So that is the amount of the EMF we can get from the Daniell cell. So if we can use exact molarity and all, so the EMF of Daniell cell, I can talk about here what is the EMF. It gives exactly the 1.0 volt. It gives exactly the 1 volt. So here the EMF, which is in another known term till now that you take for a moment at here potential difference, or the voltage what we get from the Daniell cell is 1 volt. So like that we are having one more cell, primary electrochemical cell, so which is known as Leclanche cell. So this is also a primary electrochemical cell. So in this case we will change our setup. So it's contain zinc as cathode in contact with here electrolyte is zinc chloride, and ammonium chloride as solution of electrolyte. Zinc is an electrode and ammonium chloride as an electrolyte. And here we are using a carbon anode. So that carbon anode is with a mixture of manganese dioxide and carbon powder. So in another word that we can call as porous pot. Porous pot is a carbon anode and that is a mixture of manganese dioxide and carbon powder. So to make any cell we need three things. One is anode and cathode and electrolyte. So here zinc is cathode and porous pot will be served as anode, and electrolyte we can use ammonium chloride as electrolyte solution. Let us construct this Leclanche cell first. So the construction of Leclanche cell. Let us see the construction of Leclanche cell. So to prepare the Leclanche cell, we need to prepare the electrolyte first. So here ammonium chloride is being used for electrolyte. So here we are constructing a rough amount so that to get the what is the EMF from the Leclanche cell. We are not preparing any kind of exact molarity and all. Just take water. In that water, just add the ammonium chloride. Now, the ammonium chloride will act as electrolyte. So, in the ammonium chloride, so we will dip this as our porous pot. So this will be served to us as positive. So we will dip that porous part which contains inside manganese mixture with as a carbon powder. So that will be served as our positive charge. Now that we will dip in that electrolyte solutions. In the same electrolyte solution, we need to dip with the zinc rod. So to check the potential difference, here the connecting wires has been connected so that we can connect that to a voltmeter. So to understand the what is the EMF which we can get from the Leclancer. Now this zinc rod. So this zinc rod will be served as cathode. So and porous part will be served to as anode. Now zinc rod will be dipped after connection with as a connecting wires. So we can put it that in the porous. So in the solution. Now this setup, so this everything now it becomes to us like Lancer. So this is to us as like Lancer. Now to check the Leclancer EMF, to check the Leclancer EMF, so if you connect to us that voltmeter, so porous part will be acts as positive and zinc will be acts as negative. So we can connect that to a voltmeter. So voltmeter will be show up certain reading. So the EMF, I am using again another word EMF of a cell which equals to roughly 1.4 volt. So that is the standard EMF we can get from the porous part, sorry, Leclancer. So here the main parts are to us the electrolyte, so the ammonium chloride electrolyte, and along with this porous part and our one is anode, another one is cathode. Zinc is minus and the porous part will be acts as positive charge. So the EMF of Leclanche cell equal to 1.4 volt. So here I am talking about EMF. So EMF is very needed definition right now at here. So EMF is nothing but it says a full form is electromotive force. So its electromotive force we define as is the work done by the source in taking a unit positive charge from its lower potential terminal to the higher potential terminal. So EMF it is defined as work done by the source in taking a unit positive charge from its lower potential terminal to higher potential terminal. Let me show you something. So to understand the EMF, suppose if I take a battery at here, suppose if I measure the potential difference across the battery. So now to this battery nothing is connected. There is no resistance, there is no connecting wire, nothing was there. Now the battery is showing the some value at here in the voltmeter. So here it is showing as a 9 volt. Now this 9 volt we can say to that EMF of source. So the work done by the source, to move a unit charge when there is no current flowing through the circuit. So that we define as EMF of the source. So EMF also measuring in terms of potential V volts. And we know one more definition. So this EMF I can express as work done per charge. So the work done per charge is nothing but EMF of source. So here the condition is when there is no current. There is no current should flow in the circuit, or otherwise we can say this circuit or open circuits. I think you are getting the confusion with what is potential difference, because potential difference is also having the same formula. So potential difference is also having same formula, work done per charge. It's also units goes to volts. So we can say potential difference. Suppose if we connected this source, suppose if I take in the source, I connected this source to is via a resistance to a cell. So to understand the differences between EMF and potential, so let me construct this first. So I am connecting. Yeah. Now the circuit is on. Suppose if I measure the potential difference, sorry, voltmeter across the source. Now the circuit is connected. Now if the circuit is connected, current is flowing. So if the current is flowing, we cannot say that is the EMF of the source. Suppose if I cut the circuit, if I cut the circuit at here, now the current is not flowing. So this circuit we can say that it is as open circuit. So in the open circuit, if you measure the voltage across the source, so that voltage we defined as EMF, which we can use with as a Greek letter E. So that is the exact symbol for EMF. So to understand about potential difference, suppose if I connected this circuit, suppose if I connected this circuit again, now the circuit is on. Now if I measure the potential difference across any point in the circuit, now if I am measuring potential across the resistor, so now here you can see what is the value here it is giving. Here it is given the voltage drop across the 4.50 volt is the potential difference across this location, across resistor. Or suppose if we can change, if we want to measure the potential difference across the bulb. So the potential difference across the bulb is showing the potential difference same across the bulb, also showing the 4.50. So it's also having the same. So this we can say that potential difference is also equal to 4.50. The work done per charge. Or if you can measure same potential difference, you can get at the external out. Now the potential difference across the two ends, the total potential difference. So here the total potential difference we are noticing at here. Here it is across these 2 points equal to 9 volt. So because you can sum up the two values, that we can get it. So that we can define as potential difference. But here we need to define the EMF. So EMF is defined especially in the open circuit. So what is the meaning of open circuit? Just take only a cell. Nothing is needed. Just we need a cell, a source, a battery. Just measure the potential difference when there is no external circuit is connected. If there is no external circuit is connected, what is the source having? So that we say that electromotive force, EMF. Usually it is not a force, but some historical reason given the definition in the without knowing the knowledge of the potential difference. So the first word is given to this by the Alexander Volta. So that's why So this is defined as EMF. EMF is nothing but work done per charge by the source. So its units are volts. So this is the definition of electromotive force. So we can define electromotive force as a standard definition. The EMF of a source, its first source, EMF source may be defined as the work done by the source in taking a unit positive charge from its lower potential terminal to higher potential terminal. Suppose this is cell. So this is the what the construction a Daniell cell or Lagrange cell here you can take. Let me take this as a Daniell cell. Now it's having two electrodes. This is positive electrode and this is a negative electrode. And this everything setup is kept in an electrolyte. Now the work done by the source. Here the source is the electrolyte. The work done by the source to move a unit charge, unit positive charge from lower potential difference means from N to higher potential difference to P without connection. Here there is no external load if you notice. So there is no circuit is connected. So these circuits are nothing but open circuits. So that definition we define as EMF, electromotive force. So EMF units are volt. So as per I said, EMF is not a force. Be careful. So this is not a force. So this is the work done per charge. So here one more definition I need to make you understand, that is the internal resistance. We know the resistance. Yeah, resistance we know about that for conductors or for any kind of the materials. But internal resistance. So here internal resistance it is defined as the resistance offered by the electrolyte. So the resistance offered by the electrolyte of a cell to the flow of current between the electrodes is called internal resistance of the cell. Suppose to a cell, if I connected a external load, here the external load is the resistance R. So this is my external load. R is connected. It's a load. Any resistance you connect. Now through the circuit current is flowing. So when current is flowing from higher potential to lower potential. So electrons are flow from the lower potential to higher potential. Suppose if it's the direction of the current, and electrons will flow from negative to positive. Now here the electrons has to move through the electrolyte. When electrons are moving through the electrolyte, and in the same case through the electrolyte from one point to another point. So due to this motion of these electrons, and at the same time the positive ions, they are moving in the opposite direction. So that is the electrolysis will take place. So the motion of the electrons from the one side to another side, and the motion of the ions from the one side to another side. So that causes collision. So that collision leads to the internal resistance within the electrolyte. So that resistance will obviously oppose the flow of the electrons. So this everything is happening inside the electrolyte, not the external load resistance what we connected. The external resistance here is connected just to flow the electrons, to flow the current. So to make the complete circuit, make the complete circuit at here, the electron should flow through the electrolyte. They must flow through the electrolyte. When these electrons are flowing through the electrolyte, oppositely the ions which are present in the electrolytes, they are also in the motion. So these two will move in the opposite direction. When they move in the opposite direction, so obviously there is the possibility of collisions. So they will collide with one each other. Obviously the electrons motion will reduces. So that opposing force we call it as resistance, but here that resistance is occurring in the electrolyte solution, so that's why it's called as internal resistance. So internal resistance is a pure character. It's a pure character for the electrolytes given electrolyte solution. So this internal resistance definition I can say the resistance offered by the electrolyte of a cell to the flow of current between the electrodes. It is defined as internal resistance of the cell. So here we got a new concept from cell, so that is nothing but internal resistance. So we used to represent internal resistance with a small r. Or the external resistance we are representing with a capital R, but internal resistance we are representing with a small r. So as final I can say that the factors which are depends upon the internal resistance. The internal resistance is depends upon the nature of electrolyte, yeah, because it's a character too of electrolyte. It depends upon nature of electrolyte, and it's directly proportional to the concentration of the electrolyte. Obviously, if electrolyte concentration is more, so the more ions are present in the electrolyte, that more ions are cause for the more collisions. It depends upon the concentration of the electrolyte, and it's directly proportional to the distance between the two electrodes, obviously, because the location of the electrodes in a cell, so that is the gives the time to flow of the electrons from one electrode to another electrode. So if we place close the electrodes, the internal resistance also decreases. And next point, it varies inversely as the common area of the electrodes immersed in the electrolyte. So the electrode what we selected, the electrode area. So internal resistance is inversely proportional to electrode area. And very important, the last point. So it increases with the decrease in temperature of the electrolyte. So temperature dependent factor. Internal resistance R is inversely proportional to temperature. When the temperature decreases, internal resistance of a cell it is increases. So this is a reason why the vehicles need better charging in the winter times rather than summer times. Suppose you maybe notice that a car is difficult to start. A car is difficult to start in the winter season than in summer season. Why? Because to start a car, obviously it depends upon the battery. So battery only gives the ignition. Now in winter season, the battery is internal resistance increases. Why? Because in winter season temperature falls. So when temperature falls, the battery's internal resistance increases. So it's not easy to flow. So but in the summer season, so obviously the temperature is more, the internal resistance of the cell is decreases. So that's the reason in winter's times at least we need to start our vehicle in a day. Otherwise, the charging of the battery, it goes down. So the battery loses its charging. Not only that, if you know that our mobile phones are having live charging. Suppose if this phone, if I charge 100% and I leave it for 4 to 5 days, yeah, my phone is capable to give a capacity for 1 day if I do not use properly. Suppose if I leave it for 5 days, will my phone shows 100% charging? Obviously no. The phone, even though if you switch off and keep, the battery discharges. What could be the reason? Here you can think that. Here you need to think about the internal resistance concept. Even though if you do not use, if you can keep the phone in the flight mode and cut all the signals and keep it like that. After certain days, so it's discharges. What could be the reason? And this is the major problem when we use the cells which cannot recyclable. The non-recyclable cells are having expiry date. After 12 months, if you purchase a cell made up of a 1 year before, and that cell you purchased now and you are using now, will it give maximum power or maximum strength or maximum potential difference or maximum EMF? The right word at here, the maximum EMF. Will it give its maximum EMF, which shows as a pencil cell 1.5 volt? No, obviously it's not, because it's 1 year old. So in the 1 year old, the chemical reaction what has developed between the anode and cathode, between two terminals, so that's as lost. So because of that, the internal resistance has already developed. The source has lost its entire strength. So this is all about internal resistance. So before conclusion that, so I would like to draw, till now we are using, this is the symbol for cell. So this is a battery or the cell. We are using that. But right now, along with this, so we are adding a resistance to the cell. Now this total together. Now if you can take this as, now if you can highlight, so from now onwards, so this is the symbol for cell. So this is the symbol for cell. So a cell contains, so this is, we indicate that EMF, and it is indicate that internal resistance. Internal resistance R. So for total cell, we are using a symbol EMF as E. So this is a Greek letter E. So this is all about cells and EMF and internal resistance.